everyone. Today we're going to learn about the law of cosines. It's lesson 5-8 in that pre-calculus book. As you know, I'm not going to be here, and you have a substitute teacher. And I forgot to tell you that the other day that I wasn't going to be here. But I just want to remind you that the law of sines homework assignment I gave you last time will be due on Friday. Also, the law of cosines assignment, which I'm going to give you today, it's only 3 problems long, is going to be due Friday. And the substitute teacher is going to give you a worksheet on law of sines and cosines, and it'll have a little bit of SOHCAHTOA in it as well, right? Triangle trigonometry. And that will be due on Friday as well. You're going to have plenty of time in class to work on it today. We will also have a test. Remember, we will be having the test on Friday. We'll review the first part of class, and then we'll take the test. The test will be on right triangle trigonometry, which is the SOHCAHTOA, as well as law of sines and law of cosines. And we'll jump right into that. About the second half of class, we'll take the test. And it's going to be a short test, but if you don't know this stuff, you probably won't do very well. If you know it, you should do very well. You should get 100% on it. So really study hard for this. You're going to have to use your time well today because you have to get this stuff done. I'm not going to have any excuses of not getting it done. If you don't understand in class what I teach right here on the law of cosines, go home and watch the video again. It's posted to my website, and that's where you're watching it from right now. So make sure you look at it again if you need to. Okay, so last time we learned the law of cosines, and if you remember, I'm going to just write a few things down here. The law of sines, I'm going to call it LOS, was used if you had angle, side angle, or if you had angle, angle, side. So in other words, 2 angles and a side. Any 2 angles and a side, or the ambiguous case was the side, side angle. So you were able to solve oblique triangles using those. Well, today we are going to use the law of cosines, LOC, to solve triangles that involve a side, 2 sides, and the angle between them. We call it side, angle, side. You remember this stuff from geometry. And the 3 sides. If you're given 3 sides, you can also use the law of cosines. So that's what we're going to do today. Now, I'm going to write down the law of cosines. The law of cosines can be stated in several different ways, depending on which variable you solve for. But I'm going to kind of give it to you in a general way, so you only have to remember one formula. So anyway, the formulas are in your book in lesson 5-8 if you want to look at all the formulas. So right here, we're given, this is the law of cosines right here. Given a triangle, I'm going to draw a triangle right here. I'm going to call it ABC, triangle ABC. Therefore, little a is opposite big A, little b opposite big B, and little c opposite big C. Okay, and those are the sides. And let's say that I was given, the triangle down at the bottom, I'm given 2 sides and the angle between them, a side angle side. Anytime you're doing you're solving a triangle with side angle side, you can use the formula in this format right here. Now, in your book, it's going to have it solved for, they might have b squared and instead of a squared there, or c squared, depending on what you're looking for. Really, all you need to know is the side, and I'm going to circle it right down here, the side that is opposite the angle you know. If you're given side, angle, side, we're going to use this format up here of law of cosines. And if you're looking for the side opposite the angle you're given, that's going to be the number that goes right here. Okay, so I want to find a right there. So this is the exact formula right here. So I have a squared equals, and b and c are really the other 2 sides. It doesn't matter which one's which, but I have them labeled right here. B is 12, so 12 squared, plus c is 10, so 10 squared, minus 2 times b, which is 12, times c, which is 10, and I really didn't need this triangle, did I? Times the cosine of your angle that you're given, which was 75 degrees. Okay, so notice, remember, I just kind of explained that the angle that you're given and the side you're gonna solve for the side opposite of it are those two numbers right there. Okay, so they're always the first and the last number in that law of cosines. So we're going to solve this equation. Well, this is really simple if you use your calculator, because what we're going to do is we are going to, if you see, right, if we take the square root of both sides to get a by itself, then we're given this problem right here. A equals the square root of 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75 degrees. Okay, so we're going to take the square root of all that. So what we're going to do is take our calculator. So I'm going to pull up my calculator right here. Be up in a second. And we're just going to plug it all in there. Should have had it ready to begin with. Okay, so we're going to go to the home screen, clear it out, and we want to find a, which is going to be the square root. So we pull up the square root, which is above the x squared. So we have to second an x squared. And we're going to put in 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75 degrees. And close parenthesis, and another close parenthesis. We had to close the parenthesis for the 75 degrees and then close the parenthesis to take the square root of all of that. Hit enter, and we get 13.48. I'm just going to check my mode just to make sure I'm in degree mode. I am. So 13.48 is my answer right here. So this number right here is 13.48. Okay, so I've found that opposite side. Now, really, from this point on, I can use the law of sines to finish this problem. So I'm going to make it large again right here and pull it down a little bit. Now I have two things that are opposite of one another. This is how you know when you use the law of sines, is because if you have an angle and a side opposite from one another, well, I have angle 75 degrees, and now I have also that side opposite of it. I can use the law of sines to solve for this. And so I'm going to find angle B first. So if you remember right, and when we're using the law of sines, if we're solving for an angle, we're going to put the sine of the angle on top. So sine of B over its opposite side, 12, equals angle, or sine of A, which is 75 degrees, so sine of 75 degrees over its opposite side, which is 13.48. Keep in mind, we are using a rounded value here, so it's not going to be a really good value. And I'm going to check my calculator again to see. That was 0.486. So you know what? I'm going to take it out to 0.486 just so we're a little more exact on the answer. So 13.486. Should round it to 3 decimal places, and I'm going to solve that by multiplying both sides of that by 12. Move this up here for a second. And we are going to rewrite this as, if I times both sides of this equation by 12, I'm going to get sine of angle B equals 12 times the sine of 75 degrees divided by 13.486. And keep in mind that this is not the sine, this is not angle B solved by itself, it's sine of B. And so I have to get B by itself by taking the sine inverse of both sides. And when I take the sine inverse of this side, the sine inverse and undoes the sine right there, so I'm left with B. And then on the other side, I have the sine inverse of 12 times the sine of 75 degrees all over 13.486. So I have to put that into my calculator now, and I'm going to leave it up over there. So I have sine inverse, so second sine gives me the sine inverse of 12 times the sine of 75 degrees, 12 times the sine of 75 degrees. If I put the end in parentheses for that, divided by 13.486. And I have the ending parenthesis for the whole inverse. And I hit enter, and it gives me 59.2595. We're going to round that to 59.26. 59.26. So my angle B is 59.26 degrees right here. And of course, now we can add 75 and 59.26. So I hit plus 75. That gives me that, and I can make it, and so I minus 180 from that. And I'm going to take the opposite of that, so it's going to be 45.74 degrees. 45.74 degrees. So 45.74 degrees. And I have all the parts of my triangle now. I have solved that triangle using the law of cosines and then the law of sines. Okay, so that is using the law of sines when I have a side angle side. Keep in mind we had a side angle side for this problem. We use the law of cosines in that manner. Now, all you need to know is, because sometimes you might be given a triangle where, let's just do a generic triangle, and let's say we don't have the markings, we don't have A, B, and C, or let's say the angle we were given is B. Okay, let's say we're given this angle right here, B, and let's say it was 48 degrees, and we have the two sides containing that angle. So let's say we had, this was 8, and this was, say 11. Okay? In this case, all you need to know is whatever side we're looking for, this is going to be B over here, because it's opposite of angle B, is going to be the side that I'm going to put right here. And you know what? I'm going to skip a step. I'm going to put the B equals the square root of all of this over here. So in this case, okay, once again, it's going to be one of the side squares. It doesn't matter which one. 8 squared plus the other side squared, 11 squared, minus, I got to look at the formula real quick, minus 2bc times cosine of A. Okay, so minus 2 times the 8, the side 8, times the other side 11, times cosine of the angle given, which is 48 degrees. So you don't have to memorize all of the different formulas. Just know that the side opposite the angle you're given is going to be right here. And then the other two sides are these numbers right here, 8 and 11. And the angle you're given is going to be right here. And it's the same format every single time. And then I can put that in my calculator to solve it. So that's how you go about solving them using the law of sines, or the law of cosines. Okay, on to the next problem. And by the way, if you need to pause this anywhere or rewind it, go ahead and have the substitute teacher do that. Okay, we just did some problems like this. Let's just set this one up for practice right now. we're looking for x, so it's going to be x equals the square root of one of the sides squared plus the other side squared minus 2 times one of the sides times the other side times the cosine of the given angle, which is 52 degrees. So that's how you set it up every time. Put that in your calculator and you find the x. That is the law of cosines. On to the next problem. Okay, let's say you're given side, side, side. When you're given a triangle with 3 sides, you've got to solve it using the law of cosines. You've got to modify the formula just a little bit. But we're going to stick it in straight like we've been doing it. And we're going to use, since A is the angle I'm given right here, and that's the angle I'm looking for, we are going to use that as what goes in for A. And so opposite of A is 10. So sticking it into that formula that we have, we're going to put in 10 right there. 10 squared equals, and one of the other sides squared, plus the other side squared, so 11 squared plus 12 squared, minus 2 times 11 times 12 times the cosine of A. Now, A is our unknown, angle A, and so we have to solve the equation for A. We have to get cosine of A by itself and then take the cosine of inverse to get the angle. So we have to get all these other numbers on the other side. Now, a common error is that sometimes I get students will go 11 squared plus 12 squared minus 2 times 11 times 12 and get one number right there and then divide both sides by it. But that's not following order of operation, because this 11 squared is being added to the 12 squared, and then from that you're minusing the 2 times 11 times 12. You cannot minus 2 times 11 times 12 from these numbers right here until you have multiplied by cosine of A, which we don't know what A is, so we can't do that yet. So what we're going to do, we know that the 10 squared is 100, 11 squared is 121, 12 squared is 144, and if we do a quick calculation, 2 times 11 times 12, 2 times 11 times 12, we get 264. So we have minus 264 times the cosine of A. And so I'm going to subtract 121 and subtract 144 from 100 right here. So I'm going to move this up a little bit. So we're going to go 100 minus 121. Okay, we are going to get a negative 21. And then we're also going to minus 144 from that. 144. We're going to get negative 165. So we have negative 165 equals negative 264 times the cosine of A. Okay, so keep in mind, remember, I can't go 121 plus 144 minus 264. I can't do this part right here because of order of operation. Don't do that. I have a lot of students do that. So we get negative 165 equals negative 264 times cosine of A. We're looking at this part right here. Now we got to divide. We got to get cosine of A by itself, so we got to divide by negative 264 both sides. And I'm going to write it over on this side. So I have, and the negative divided by negative is a positive, so I have 165 divided by 264 equals the cosine, because these cancel out over here, cosine of A, angle A. And we are going to just put that into our calculator. So, and we got to find the cosine inverse because we're trying to find angle A. So we're going to go second cosine, and 165 divided by 264, and we are going to get 51.5 let's say 51.32 degrees, 51.32 degrees. So A equals 51.32 degrees. There's angle A. Okay, so now I know angle A. What was it again? 51.32 degrees. 51.32 degrees. Now, I've got to find one of the other angles. I can use, at this point, I can use the law of sines because I know a side and an angle that are opposite from one another. So right here, we can go, and we're looking for an angle, so I'm going to call this angle B up here. We're going to go cosine of B over side opposite, 11, equals cosine of A, which is 51.32 degrees, over 10. And times both sides by 10, so 10 times the, times both sides by 11. Sorry, so I have cosine of B equals 11 times the cosine of 51.32 over 10. And then, of course, I'm going to do the cosine inverse of that. So second and cosine, and I'm going to go 11 times the cosine of 51.32, close that parenthesis, divided by 10, close the parenthesis for the inverse, and I'm going to get 46.57. 46.57. So 46.57 degrees. And then from there, we can add those two up, subtract from 180 to get the angle that goes down here. Okay, that is the law of cosines. That's how you solve for sides or angles, if you're given side angle side or side side side. And here is your assignment. 3 problems, 11, 13, and 27. Now, after you get done doing problems 11, 13, and 27, you have a worksheet that the substitute teacher is going to give you. And one of the problems asks you to find the area of a triangle using Heron's formula. It's a way of finding the area when you're given the 3 sides of a triangle, and sometimes that's the best way to find the area instead of finding the height of one of the sides, just by using Heron's formula. And that formula is found on page 330. Okay, the page before your assignment. And so you're going to need to look for that. It's a pretty simple formula. Just got to find S and then substitute the sides in and S into that formula and solve it. Put it in your calculator. That's called Heron's formula. So just a reminder, we're having the test on Friday on SOHCAHTOA, on law of sines, and the law of cosines. And we are having, and we'll review the first part of class. All your assignments, the law of sines I gave you last time needs to be done, the law of cosines, the 3 problems here, as well as the worksheet need to be done on Friday. I can answer a few questions right at the beginning of class. It will be part of our review, but we won't have time for very many of them. You need to have the assignment done. Good luck studying with this. Work hard. If you need the teacher to replay this, for some of you, go ahead and replay it and listen carefully. And good luck with it all.